Thank you, Professor Mazumdar, for that wonderful talk. So we learned of some rather grim realities of our planet. I want to talk about hope, and that's why I have a happy picture here. And that hope lies with all of us. But before I start with hope, I want to give a little snippet of a few more realities. So here are some of the news headlines we've had within the recent past. And if we learn anything from the previous talk, clearly these news headlines do not sound very helpful. But I'm not here to talk about the policies. These policies, if we want them changed, we'll have them changed. I'm hopeful, I'm sure we'll have them changed. But that will take its own course, that will take its own due time. What I want to talk about is what we can do now. And like I had mentioned earlier, that voting is a very powerful tool of democracy. Voting only empowers us once in 4 years or once in 2 years. What I want to talk about is, in my opinion, an even more powerful tool of democracy, one that empowers us every day, and that is citizen science. So, I want to start by first of all acknowledging that each and every one of us present here in this room is taking some action or the other to fight climate change by reducing our carbon footprint. So some of us have reduced our automobile usage. Some of us have minimized our plastic consumption. Some of us very diligently recycle. Some of us have cut down on our meat consumption, and there is more. But as good as these actions are, and by no means do I mean to undermine the value and the importance of these actions, these are still what I call as passive actions, and there is a need to do more. What we learned from the previous talk, how fast things are changing. The most recent IPCC report warns us of even severe effects of climate change within the next 15 or 20 years, so it's a race against time. So let's talk about citizen science. What is citizen science? But first of all, who is a citizen? Clearly, here citizen doesn't refer to a citizen of a nation or a country, it's the citizen of the planet. So as long as you were born on this planet, you are a citizen and can take part. Citizen science, in a nutshell, is a crowdsourced scientific research. It's the public participation in a scientific project. Citizen scientists are volunteers who donate their time, effort, and resources towards a scientific project that is of their interest. The citizen science projects are always led by a qualified professional in that field. However, the volunteer citizen scientists participating in the project, for the most part, are non-professionals in that field, and that is the uniqueness of citizen science programs. So for example, you are from, say, arts background or business background, engineering background, medicine background, but you've had an interest in something very different, let's say astronomy or environmental science, which is what we are talking about today. So citizen science connects these individuals with their interests to the respective science projects, such that then the science projects can benefit from their enthusiasm. So essentially, citizen science harnesses that enthusiasm, that interest from those individuals, and channels that interest into a more organized direction such that they can then contribute to a science project. So it's a win-win situation for both the parties. The citizen science projects benefit from these volunteer citizen scientists, from their interest, and the citizen scientists benefit from getting engaged, and meaningfully so, in a science project that is of their interest or they care about. So in a way, citizen science transforms hobby into science, or vice versa. One other benefit of citizen science, other than the fact that it helps advance the science, and actually this benefit applies particularly to citizen science projects in environmental science, because citizen science engages people and involves people in science projects. So now, when the people are involved, and when the public is involved, they are more engaged, they are more informed, they are more aware of the environmental issues that face them. And so they are not only more responsive, they value conservation, and so now they are involved in the decision-making process. And that is the other benefit of citizen science, that it facilitates a bidirectional flow of communication between local governments and the communities, so that the policies are designed in consistent with the needs of the communities. And we have an example of this up in Delaware City, and like I mentioned, we'll have a talk in the series later on. Another unique benefit of citizen science is that it makes that research possible which is not possible by any other means. So in other words, citizen science is the only mechanism by which those kinds of research can even be realized. And I'll talk about some of the examples later on. There's a vast gamut of citizen science projects, and it's very likely for you to find something of your interest. To learn more about citizen science, I would encourage you to read the January issue of the Project Nature newsletter, in which I have laid it out in much more detail. Okay, I want to talk about some of the contributors to climate change, because when we think of climate change, the foremost thing that comes to our mind are greenhouse gases. And sometimes that's the only thing that comes to our mind. But there is much more to climate change. There are many other contributors to climate change. So let's talk about those, but let's start with the most obvious one, the greenhouse gases. With the greenhouse gases also, there are sources, and then there are sinks. Among sources, we have our usual suspects, industries, automobiles, but then we also have agriculture that plays an important role, that makes a significant contribution. And then we have these sinks. Now, sinks are the mechanism that capture the carbon which is in the atmosphere as a greenhouse gas and sequesters it. So among sinks would be the forests. We know that green plants take sunlight and carbon dioxide and convert it into organic matter, plant tissues, by the process called photosynthesis. So in a way, what they are doing is they are capturing the carbon that's otherwise in the atmosphere and sequestering it. It's estimated that plants convert approximately 100 billion tons of carbon dioxide every year in the form of plant tissue. There is something. It's bad. Another land-based sink would be the soil. Soil sequesters carbon in the form of organic matter, and soil actually captures or sequesters 3 times more carbon than all the living plants. So it's a major carbon sink. Last but not the least are our oceans, which are actually the largest carbon sink. They capture carbon in many ways. The surface water dissolves the carbon dioxide and hence keeps it from the atmosphere. Marine plants like phytoplankton, which is a microscopic photosynthesizing algae, which takes the carbon dioxide and converts it into organic matter. And actually, phytoplankton is responsible for the majority of oxygen that we have in the atmosphere. Marine animals that have an exoskeleton, that hard shell is made up of calcium carbonate. That is another mechanism of sequestering the carbon. With oceans, however, there is a small caveat. The more and more carbon dioxide we keep pumping into the atmosphere, the oceans keep absorbing it, dissolving it. And for some time it was thought that that's good, because that carbon dioxide, which would otherwise be in the atmosphere as a greenhouse gas, is being sequestered in the water. Now we have learned that the increased CO2 that's dissolved in the atmosphere is causing the oceans to be more acidic. It has been estimated that since the advent of Industrial Revolution, the average pH of the oceans has decreased by as much as 30%, which means the acidity has decreased by 30%, and that is taking a toll on the ocean ecology. So all these positive contributors that we talked about oceans, they are getting impacted. Anyway, so the larger point here is that we are impacting a double blow to our planet. Not only are we increasing our sources, we are shrinking our sinks. So when we think about solutions to fighting climate change, it just doesn't involve reducing the sources. So just the electric vehicles or the more fuel-efficient vehicles, hybrid vehicles, are not going to solve the problem alone. Yes, we need those. We do need to reduce the emissions. But we also need to make sure that our sinks are in place, that we manage our sinks well. Okay, let's talk about some of the other factors that often get overlooked. And we don't talk about those, but those are so very important factors to climate change. One of those factors would be the land conversion for, say, agricultural use or extraction of resources such as mining or building a dam. Now, what that does is it disrupts the ecosystem. One other very, very important contributor to climate change is the introduction of non-native invasive species. Now, these non-native invasive species, plants, animals, or even fungi, either introduced deliberately or accidentally, they quickly adapt to the local ecosystem, local environment, and they are so aggressive that they just disrupt the entire ecosystem. So an example of a non-native invasive plant would be that of a honeysuckle. It's a menace. Because that plant did not evolve in this ecosystem, it does not serve any purpose in the ecosystem. Its berries aren't very nutritious for the native wildlife. Its root system isn't very strong enough to hold the soil and prevent erosion. And it is such an aggressive plant and such a smart one that it starts growing very early in the spring, well before the native trees higher up develop their foliage, so it can take all the sunlight and sucks out all the nutrients from the soil before the native plants could take it. There are many other examples of these non-native invasive species: garlic mustard, Calvary pear, multiflora rose, and their list is long, so they pose a significant threat. Among non-native animal species, a very common example would be that of the house sparrows that we have all around here, or the European starlings. They have posed a serious threat to our native cavity nesters like the bluebirds, Asian carp in the Illinois River, Burmese python in the Florida Everglades. These are other examples. And actually, this month, from the week of February 25th to March 1st, is the National Invasive Species Awareness Week. See, I was not kidding about this being an important issue. And actually, Blacklick Woods Metro Park is doing a public program on February 23rd and 24th, which is a weekend, Saturday and Sunday. And they'll have lots of displays in their nature center, which is open from 8 a.m. to 6 p.m. And a great deal of information about these invasive species. So do check that out. And I have this event listed in the current issue of the Project Nature newsletter. So check that out if you get a chance. One more very, very important contributor to climate change is loss of habitat. Now what that does is that it impacts the animals that depend on it. Again, I can use several examples here, but let me use just one example that directly impacts us, and that is of the pollinators. Now these pollinators are essentially mostly insects like butterflies, moths, bees, and because of the habitat loss, they are suffering a huge hit. Their numbers are critically declining. They are declining at an alarming rate. And why should that bother us, or why should we be concerned? Because our agriculture depends on these pollinators. More than half of our agriculture depends on pollinators. There are only a few crops like wheat and rice that are wind pollinated. Most everything else that we eat need pollinators. And while modern technology has made so many advances with the newest tools in farming that we can do more efficient farming with greater yield, new technologies that you can do farming on rooftops inside a building. We even have technology now that you can do farming without soil, just with nutrient-rich water. But to this date, there has been no technology that has been developed that could replace a pollinator. So our agriculture desperately depends on these pollinators. And if you think about it, human civilization stands on agriculture. We have come a long way from hunters and gatherers. And if agriculture were to collapse, the human civilization, at least the civilization as we know it, would collapse. So if we need to ensure our existence, we must ensure that these little guys can survive. We need to make sure that we can provide them with sufficient habitat that they can thrive successfully. So these were just some of the points that I wanted to highlight, which often get overlooked, ignored, we don't talk about it, but they need to be addressed. And they are very significant factors to climate change. Okay, I want to quickly talk about ecosystem because I tossed around that term a bunch of times in the previous slide. And I'll tell you in a little bit why I wanted to talk about ecosystem. Just bear with me, give me just a couple of minutes. So what is an ecosystem? An ecosystem comprises of plants, animals, their natural surrounding, which is their habitat, and their interdependence with one another. That entire thing encompasses an ecosystem. A more formal definition of an ecosystem would be that an ecosystem has producers, consumers, and decomposers. So among producers would be the green plants that take sun's energy and convert it into more complex chemicals, the plant tissues, which can then be eaten by the consumers, which would be the herbivore animals. The secondary consumers would be the carnivores. And finally, the decomposers, such as the bacteria that derive energy by digesting the waste organic matter. So in this way, energy, nutrients, and water constantly cycle through an ecosystem. Let's take a quick example of a specific ecosystem. Let's talk about forest ecosystem. We've already established how good carbon sink forests are. So in a forest ecosystem, we have insects, which are the pollinators, and help fertilize the plants, and hence they can reproduce. The birds and other mammals that live in the forest, they eat the fruit and disperse the seeds. So they are the mechanism of seed dispersal. The subterranean critters living underground, such as the earthworms, they burrow into the soil, thus aerate the soil, allowing the roots to breathe. Their castings leave valuable nutrients for the plants. Even smaller contributors in a forest ecosystem would be the microbes, such as the bacteria, the fungi. that break down the organic matter into even simpler units that the plant roots can then absorb. So in this way, every element in an ecosystem is intricately interconnected and plays an important role in the smooth functioning of the entire system. If one element is impacted, it affects the rest of the system. Another easy and rather interesting way to understand ecosystem is, and actually this is a relatively new field of study altogether, where parallels are drawn between how money flows in an economy and how energy flows in an ecosystem. So just like there is a budget in an economy, there is an energy budget in an ecosystem. Just like there are banks in an economy which regulate the flow of money, there are energy banks in an ecosystem that regulate the flow of energy. So large, big, heavy herbivore animals would be the energy bankers of the ecosystem. Just like in an economy, if it's more diverse, it's more healthy and stable, same with the ecosystem. And just like in an economy, if there was a recession in one part of the economy, if there was a recession in the US economy, it leads to global recession. Same with ecosystem, if there was a recession in one part of the ecosystem, it impacts the rest of the system. Okay, enough about the ecosystem, but why did I want to talk about the ecosystem? The reason is that when we think of climate change, we tend to imagine these massive scale events. We think of these large scale wildfires. We think of these devastating hurricanes that wipe out entire town. We think of sea levels rising. We think of the Antarctic ice sheet breaking apart, and we get overwhelmed. And we feel ourselves so small in the face of this massive problem that is climate change that we just feel defeated right away. So, like we said about the ecosystem, that every element in the ecosystem is very intricately interconnected, and plays an important role in the smooth functioning of the system, such that if one element is impacted, it impacts the rest of the system. If we take that statement and turn it upside down on its head, it also means that if we conserve or restore one small element of the ecosystem, it will have much, much far-reaching effects. And that's how I would like us to think about when we think of solving climate change or fighting climate change. We do not need to overwhelm ourselves with these large-scale problems that we feel are way beyond our control. We can start by conserving the smallest of the elements in the ecosystem that are well within our reach, well within our control. We conserve that, we restore that, and that will have far-reaching positive effects. Okay, how can we get involved? Finally, okay, so there are several ways to get involved. Let's talk about those. The easiest way, I would say, is the invasive species removal drives. We just talked about the importance of the impact of these invasive species, and starting spring every year, spring through summer, we have to remove all these invasive species. So these drives happen all around the city, organized by all these different organizations like Nature Conservancy, Metro Parks, FLOR, Friends of FLOR, Olentangy Watershed. And again, if you sign up, I will be sending information about all these drives. So these invasive species removal drives are typically a day-long event. And when I say day-long, that doesn't mean that you have to be there for the entire length of the day. Remember, it's a volunteering job. So whenever you can and for however long you can. Another way to get involved would be the restoration projects. So restoration projects are taking care of, we talked about the loss of habitat. The restoration projects are where we are restoring the habitat. So examples would include setting up new bluebird boxes, restoration of a wetland, restoration of a river riparian, restoration of planting a new pollinator garden. So, and all these activities not only are they fun, they are extremely informative. You will learn so much every time you go there. And it's just a rewarding experience. When you get hands-on involved, you will feel that yes, you made a difference. And as I mentioned that there are several opportunities all over the city, there are opportunities right here on campus to get involved. One such place is Chadwick Arboretum. Chadwick Arboretum is a beautiful place here on campus. And we talked about the problem with the loss of habitat. So Chadwick Arboretum could be considered a small little pocket of nature refuge for the wildlife amidst this heavily developed urban area. And there are lots of projects that happen at Chadwick Arboretum that they need help with. They can use all the help. They're terribly short-staffed, so they can use all the help they can get. So that's where that's one of the places that you can get involved right here on campus. The other place that you can get involved on campus is with FLOW, the Friends of Lower Olentangy Watershed. They have lots of restoration projects, invasive species removal drives that happen right here on campus along the river riparian. And actually, I'll just quickly point out, if you go to this URL right here, that's the homepage of Project Nature. And on this homepage, well, first these are the Project Nature newsletters that are archived. But if you go to the Get Involved page right here I'll be listing the different organizations where you can get the opportunities. But then I have this announcements right here where any opportunity that comes available, I will be posting it here. So stay tuned, keep checking that. For instance, this Saturday, Metroparks is hosting a public event to talk about the many volunteering opportunities they have at Highlands from 2 to 4 p.m. And then Saturday, February 23rd, Flow is organizing a river cleanup right here on campus by Lane Avenue along the bike trail. And that's the first part. Then they'll have invasive species removal. So as and when those dates get solidified, I'll be posting those here. And you can check that. And again, if you sign up, I will be sending information about that. Okay. One more thing with which you can get involved with, which in my opinion is the most exciting, most fun, most enriching, most rewarding experience of all, and that is the biotic or biodiversity surveys. So I have planned on talking a lot more about these biotic surveys, but in the interest of time, I'll skip all this. But quickly summarize what's the importance of these biodiversity surveys. So we talked about the ecosystem, the importance of ecosystem. So understanding the environmental problems we are facing today, we need to have a good understanding of the ecosystem so that appropriate policies and actions could be informed. And to understand the ecosystem, we need to document what is in the ecosystem, and that is what these biodiversity surveys are. So it's like a bird survey, or a butterfly survey, or a dragonfly survey, not just animals. Wildflowers, trees, even fungus, mushrooms, lichens, it's everything that is in the ecosystem needs to be cataloged. And that's where citizen science plays a key role. Citizen scientists, the volunteers, contribute a great deal to these surveys. And they are badly needed. And I'll skip all this, but since I had mentioned earlier that there are certain research which are simply not possible without citizen science, so I just want to highlight one example here. So this is a range map of a bird, white-throated sparrow. The range map essentially tells you where the birds are in which season. So typically the migratory birds would be, in the northern hemisphere, would be migrating to higher latitudes because the days are longer and that's their breeding season. So they have more time to nest, to raise their young, to collect food. But as winter sets in, they retreat back south. So these range maps tell you where they are, what migratory routes they take. And not only are these range maps important in that they tell us about the ecology, they are actually very good, actually one of the first indicators of climate change. Any deviation from the set range maps are a clear indication that something is wrong. And there might not be anything else that we can perceive, but these things will be the first indicators. But the point here I wanted to make was that the only way these range maps could even be drawn is because of citizen science. It's not possible, it's practically not possible for a group of few scientists, few ornithologists, 100, 200, 500, or 1,000 ornithologists to just 2-3 years just chase after birds, where they go, where they land, where they refuel, what routes they take. It's practically not possible. The only way these range maps could even be realized is when hundreds of thousands of citizen scientists all over the North American continent contribute their observations and send it to a centralized repository. So Cornell Lab of Ornithology has several citizen science programs, one of which is eBird. And we'll actually dedicate one whole lecture in the series on eBird. So in eBird, all you need to do is you saw a bird somewhere outside your window while you were driving, while you were taking a walk. You need to just report what bird you saw, when you saw, and where you saw. So while an individual's contribution might seem small, but when hundreds of thousands of these citizen scientists contribute their observations to a centralized database, it becomes a treasure trove, a wealth of information for these scientists to not just draw these range maps, but also study and analyze the data and draw trends. Okay, so I'll skip all this in the interest of time. Oh, here is a beautiful quote from my good friend and the state coordinator of Ohio Dragonfly Survey, Melissa Spring, here in the audience today. I had once asked her that in her professional opinion, what was the importance of these biodiversity surveys? And she very eloquently said that we know that the physical systems of our planet is changing quickly. We are losing species at a much faster rate than ever before. So we need to keep a track of the changing ecology, changing ecosystem. So we need to know what we are losing. But how would we know what we lost when we did not even know what we had in the first place? So the importance of these biodiversity surveys cannot be overstated. And like I said, these are absolutely exciting. I can just go on and on talking about these biodiversity surveys, but I'll get to the more relevant and more important point that you might have a question. Well, I don't have any experience or knowledge. How can I even join these surveys? How can I even contribute? So first of all, these surveys are always led by an experienced naturalist who are always happy to have new people. They are always happy to talk about what they know. So they will take all the time and effort to educate you, to teach you the nuances. So you start learning from day one. But what's more important is that you start contributing from day one. And trust me, I'm not just saying that to make you feel good or just encourage you. I'll tell you why and how you start contributing from day one. So say it's a butterfly survey or a bird survey, where things are flying all around. When you join for a survey, you are bringing with yourself an extra pair of eyes, an extra pair of ears, which doesn't apply to butterflies, but it does apply to birds, and an extra pair of hands. So say there were two very experienced naturalists doing the survey. They still have a very limited vision. And when things are flying all around, if you are there to help them, you can sight something which was not in their field of vision, and you can tell them. You may not be able to identify what it was, but you can tell, yeah, that looks like a bird, and they can then identify. And then and there you have made a very significant contribution, because had it not been for you, that species would not have been recorded, and so the data would not have been accurate. Also, like for butterfly survey, we are carrying nets, we are carrying jars, we are carrying any survey. When we are in the field, we are carrying a notepad with not notepad, but the clipboard with a data sheet. So you can help out with those things such that it frees the hands of the more experienced members in the group, and then they can use all their resources in citing whatever it's a bird or a butterfly or anything, and they can work on identifying the species. And like I said, it's just a fun experience, and there are, I've already mentioned this, that we are documenting the entire ecosystem. So there is such a wide variety. You may not be interested or excited about birds, not butterflies. You may be interested about maybe in moths, or maybe you don't like things that are flying around. Maybe you like things that are stationary. Maybe you like trees. Maybe you like wildflowers. So there is so many options that you can. It's easy for you to find something that interests you. One other very important question that I always get whenever I'm talking to someone and trying to encourage them to get involved, and that is commitment. Well, how much do I need to commit? Well, it's a volunteering job. You cannot be fired from a volunteering job. There is no commitment. So when you can join, and for however long you can join. And say for instance, there was a survey happening or invasive species removal drive, and you emailed that, hey, yes, I want to sign up for it. But then on that day something happened and you couldn't make it. So you made a commitment, but you couldn't make it. And that's perfectly okay. There are no hard feelings. Everyone understands that you have a day job. You are just volunteering, you are donating your free time. So absolutely no problem if you are not able to make it. And I'll go so far as saying that even say you were able to contribute 1 hour in an entire year, even that counts. And it's not only appreciated, you have made a difference in that 1 hour. And again, you might have contributed 1 hour, someone else contributed 1 hour, someone else contributed 1 hour, and all that adds up. So do not hesitate in signing up and trying for it. Since I said there is no commitment expected, there are just a very few exceptions in which some level of commitment is expected. So for instance, if you were a bluebird monitor, well, yeah, you must be checking your boxes, nest boxes once or twice mostly once every week. But there are only few of these projects that require some level of commitment, but rest everything, no commitment expected. Like I said, join whenever you can, for however long you can. And again, I would say get involved in the project that interests you the most, that you feel comes naturally to you and is the most exciting, because once you find that project which is the most exciting to you, then commitment becomes a recreation. And that's how I would like you to treat nature involvement. I would not like you to treat nature involvement as a moral obligation to Mother Nature, Mother Earth. That's good at the background, but it's not very healthy. It's not very, because you are feeling guilty if you're not able to make it. Instead, if you make it into a fun activity, a recreational activity, then you do not need any external stimulus. You do not need any external driving force. So again, I'll end this with all these different organizations that you can volunteer with. And one last thing that I want to talk about is, and I'll end with this, is iNaturalist. So this is the most exciting, the easiest and the most fun way to contribute to these biodiversity surveys. iNaturalist is a digital platform. It's a shared database, and we are living in the age of digital information technology. Everything is benefiting from information technology. Why not citizen science? So the official description of iNaturalist on its website is that it's a social network of the community to share their biodiversity information or observations. I like to call iNaturalist a real-life Pokemon Go. It's a Pokemon Go with a purpose. Because all you need to do with iNaturalist is, it's so easy. There is no set time for any survey, no commitment. You are out in the field doing something. You're taking a walk, you're playing frisbee, and you saw something, maybe an interesting bird or a tree. You just take a picture of it and upload it. And the most wonderful thing about iNaturalist is that you do not need to know the ID of that. You do not need to know what that bird is, what that tree is. And so it becomes an educational tool, because once you upload it, the community will identify it for you. So you not only get to learn what you saw, you have also contributed to this biodiversity survey. So we will actually have a whole lecture on iNaturalist, because it's such an interesting and a fun tool to play with, and through that enjoyment make a significant contribution in adding to the biodiversity information. So I'll skip this, because for this slide I'm anyway guilty of self-plagiarism. I have just lifted off from the January issue of the Project Nation newsletter, which you can read. And with that, I will thank you, and please don't forget to sign up, and I'll take any questions if you have.